Hello, this is John Davison. I'm a graduate student at Georgetown College, and this is my presentation for my Capstone research project as part of EDU 626. This study examined gifted and talented high school students and their teachers' perceptions on effective and ineffective classroom strategies in high school science classes. I'm defining effective to mean what helps students learn and retain the material, not just get a grade. The goal of this study is to determine the difference in student and teacher perceptions about what works in the classroom for gifted students and align those strategies to increase student interest and engagement in science classes. Which led me to my research question. What classroom strategies do high school gifted and talented science students and teachers perceive as the most effective in mixed science classrooms, and why? In my research of the literature, I found three broad themes: strategies for gifted students in general, strategies for gifted students in science specifically, and the longitudinal effects of differentiation for gifted students. This triangulated mixed methods research study contained both qualitative and quantitative data and was carried out in a rural high school in central Kentucky. The goal of the study was to determine the perceived effectiveness of various classroom strategies for gifted students in mixed science classrooms, mixed being that they have both gifted and non-gifted students, from both a teacher and student perspective. The qualitative and quantitative data were collected at the same time via a survey given to the students and the teachers. There were 17 different strategies that students and teachers could rank on a Likert scale, from 1 being very ineffective to 5 being very effective. Additionally, there were 3 open-ended responses, which is where I got my qualitative data from. Completed surveys were returned from 117 gifted high school students across all grade levels. Surveys were also completed by 4 science teachers, 3 males, 1 female, all of whom have over 10 years teaching experience. The student demographic data can be seen in figures 1 and 2 below. All participants were asked for consent or assent prior to participation. No names or identifying data were placed on any student survey, and no names will be associated with any additional feedback. Student participants were informed that all participation was voluntary and that they were not required to complete the survey in any way. Once this capstone project has been completed, all surveys and associated notes will be destroyed via shredder. The participating teachers assisted with data collection by handing out the surveys in their advanced science classes and allowing the students who wished to participate class time to complete the survey. The total time to complete the surveys was estimated to be 5 to 10 minutes, depending on how much the student participants wrote for the open-ended questions. The participating teachers reported this was an accurate estimate. They also completed their surveys at this time. Once the surveys had been collected, the quantitative data was entered into an Excel spreadsheet so that the averages and standard deviations among the answers could be easily calculated. The open-ended responses were transcribed into a Word document where the data was coded based on word frequency and whether those words were used in a positive or negative context toward the various strategies. Overall, students ranked the strategies of demonstrations, hands-on lab activities, and group discussions as the most effective, and ranked assigned readings, goal setting, and specialized software or internet sites as the least effective. These results come from the quantitative portion of the data. You can see a graph here that represents those highest and lowest ranked strategies. Strategies that fell somewhere in the middle were left off of this graph due to space considerations. The highest rated strategies of demonstrations, hands-on lab work, and group discussions had effectiveness scores of 4.47, 4.38, and 4.21 respectively. The next highest rated strategy, problem solving, had a score of 4.02. Each of these 4 strategies had standard deviations of less than 1, which was the smallest among the ranked strategies, showing a high level of agreement among what the students perceived as the most effective. The lowest ranked strategies, which all had effectiveness scores of less than 3, also had higher standard deviations, around 1.2. This shows that while these strategies were generally seen as less effective, there were students who found them effective. The results changed very little when broken down by gender or class. Table 2 below shows the highest ranked strategies by gender and grade. While the order is somewhat different among different demographic groups, the highest ranked strategies remain constant across groups. A similar trend is seen among the lowest ranked strategies. The quantitative data showed a clear preference for hands-on and more interactive learning strategies. The same trend was seen in the qualitative data as well. The open-ended responses were searched for repeated words and themes. Table 3 below shows the most commonly occurring words and themes and how many each were mentioned, and in what context, positive or negative. As you can see, hand or hands-on learning was mentioned 40 times, 39 of them positive. Visual or being a visual learner was mentioned 17 times in a positive way, whereas reading, computers, and being bored or boring were mentioned 16, 11, and 9 times, respectively, all in a negative light. There were some classroom strategies not in the survey, but mentioned often by students in the open-ended responses. They included note-taking, field trips, and individual projects. Note-taking was mentioned by far the most, with 13 individual mentions. Sample student responses include, I like to take notes because writing and hearing content helps me reinforce it in my memory. This was somewhat surprising, given that note-taking is not a particularly interactive or hands-on activity. That said, a gifted student who is interested in the material and wants to learn might be engaged simply by learning new things and may view note-taking as a more hands-on activity as they are engaged in their own learning. On the teacher side, quantitatively, they ranked subject matter experts and independent research as the most effective, and pre-assessments and goal setting as the least effective. However, given the small sample size of teachers in the survey, the open-ended responses reveal much more nuance. One teacher indicated that when students are responsible for their own work and learning, then it has a much more meaning to them, provided they have the necessary fundamental background knowledge. Another teacher indicated that a well-led group discussion that leads students to asking higher-level questions prompts curiosity and a higher retention level. This kind of discussion and questioning technique would make sense with a group of gifted students, as their curiosity about various subjects would likely be higher than a regular student. Goal setting was ranked low by both groups. One student put it best, saying, "You can't force other people to set goals." This was a sentiment shared by teachers. Pre-assessments were also not viewed favorably by teachers. I am more concerned with what they know at the end of the unit, regardless of what they know before. This mirrors the sentiment of many students as well. One teacher also remarked that some of the strategies marked low work great for some classes but fail with others. This is obviously true for both students and teachers, as even the highest ranked student strategies had some who did not find them effective, and even the lowest ranked had some who find them helpful. Connecting this research back to the literature, the more hands-on and interactive strategies favored by the students fits well with research done by Horak and Galuzu, which compared two groups of middle school science students, one group that was taught using a project-based learning approach that was more self-directed and hands-on, and a control group with a more traditional method. By the end of the unit of study, the project-based group scored higher on the unit test and reported a higher level of satisfaction and perception of classroom's quality. Independent studies, which was favored by the teachers, fits well with research done by Van Tassel, Baska, and Hubbard, which talked about independent research projects for gifted children, especially in rural districts, which worked best, according to them, if it was organized and tailored to ensure that it was optimal for the student. This ties in very well with one of the teacher-generated comments that students learn more if they are responsible for their own learning, so long as they have the necessary background information. While the strategies that gifted students and their teachers perceive to be the most effective do not line up perfectly, there is a level of agreement that students must be engaged in and responsible for their own learning. Whether that most effective form is a hands-on lab, a group discussion, or independent research may be a matter of personal preference, but it's clear that engagement is the key. Readings that are boring or work on a computer that is not tied to a specific interest area should be used in a limited way, perhaps as a reference or a backup. Both groups rated goal setting as one of the least effective strategies for learning, so any goal setting must come from the student or students and what they are motivated to achieve. Future research in this area could include a larger group of teachers, either by soliciting science teachers from multiple schools to participate, or by broadening the research to include teachers from more subject areas. Additionally, I would include the strategy of note-taking, since it was mentioned so many times as an additional strategy that the students found effective. Here are my references. Thank you for listening, and have a good day.